So, welcome everyone. Thanks for coming for this meetup tonight. And tonight I want to show you some basics in observability in Spring in the context of Spring Framework version 6 and Spring Boot 3. So, yeah, I'm the backend lead developer at Supercharge, and I'm developing Java applications for about 10 years, but enough about me. Let's go for Spring 6, what it has for us. So we were waiting it for some time now. Spring 5 was released around somewhere 2017 or something like that. And the Spring 6 came out just last December the 30th. It supports a new baseline Java version, Java 17, opposed to the Java 8 that was supported by Spring Boot 5, Spring Boot 2, and Spring Framework 5, which means some security improvements, performance improvements, but most importantly, some new language features that developers can use to make Java a bit nicer to use. By the way, in Spring Framework 6, some Java 19 features are already supported. We will look at that a bit later. New baseline for Jakarta Enterprise Edition also introduced with the baseline of version 9, with some support for version 10 already. This means better and faster Java Enterprise support because from Java Enterprise Edition, the Jakarta Enterprise Edition is now maintained and stewarded by the Eclipse Foundation and not Oracle. So that's a welcoming change. But other than the base platform support, what other new stuff we get in Spring Framework 6? So just a quick list from some highlights. For example, one new thing is problem details. So if when we are developing backend applications, we need to communicate if some error happens in our side to the front end. And every project, every company has its own problem or error response library. At Supercharge, we even open sourced one. But this problem details stuff is based on an RFC, so it's quasi web standard. And if we look at some real use cases, so when we try to get an error message out of the old Spring Boot 2 application, we get the standard Spring error JSON, which is fine. But with the new version, you can see that it gives us this new error program details version, which includes some more context for the client to handle the error or to display the error. And the standards also includes extension points. Anyway, we tried these features out even when Spring Framework was in the RC1 status, and we already discovered that this problem details not works consistently because it still gives back the good old Spring error message when we try to cause some internal uncaged server errors. Anyway, that's just a little quirkiness that usually we have with Spring. So next up is AOT as ahead of time compilation, which makes it possible for us to compile our applications into GrailVM native images. This has the promise to create a more performant and memory efficient application, which starts up much faster than it does with the JVM runtime. The Java interface client is a bit odd one in this list because we already had some other libraries that can invoke external APIs. But the Spring team decided to introduce this new approach So previously, if you wanted to invoke a third-party API and you don't have an SDK for that, then you use the Fin client, which was just a Java interface with some Spring MVC annotations. It has its own problems because this can cause security issues if you misconfigure the component scanning. And also, Fin clients are inherently blocking, so you don't have much other choice there. The Spring guys had some other libraries that support reactive programming, but in the Spring 6, they introduced this new Java interface clients with new annotations. This is an explicit choice for them, or a direct choice for them, because they wanted to separate the Spring MVC stuff from the client, from the HTTP client stuff, and also the naming is try to reflect that it is not a blocking. You can use it as a multi-paradigm or a multi-purpose interface client. So if you use here response entity, request and response entity, or reactive types, then it understands your intention and will work in a reactive way. So to use it, you will have to include Spring Flux into your dependencies. So the baseline is reactive, and but you can use it as a blocking client. Also, with the Java 17 support, you can use records, and it works just fine. Other than that, the new interface clients need some manual creation, so you need to use this factory method, these factory steps to get a client. But other than that, you can use this client just like any other good old Spring dependency. So let's just look at some quotes here, if we have these. So that's enough from the Java interface. Next thing is virtual threads, which is supported, but we are not quite there yet, because in Java 19, it's only enabled with a feature flag, with an experimental flag, but the Spring Framework team already works actively to refactor their internals and to get rid of all the thread locals they were using previously. And one new addition to here is observability. So with Spring Actuator, we already had some features which showed us the internal workings of the framework and our application. And they take this thing one step further. They created a new library, the Micrometer library, which includes all the new stuff that all the stuff they discovered during the previous iterations of the framework, and published this as a library for others to use. Which is nice because now you can't use it with any Java application supposedly, but you can also use this to instrument your business logic and get some added benefits there too. So yeah, these features are cool, but not all of this makes sense when we are working with an application that we are working on for months or years, because some of them needs key infrastructure components to be replaced, or you need to refactor many of your code, like with GraalVM. So what is this? Why would you upgrade to Spring 6? What is the added benefit here? So one thing that you can easily get is this observability feature. So the observability feature can be used by only including a new dependency, and it kicks off all the internal the Spring's internal observability tools and instrument the framework and some of your code that you have. So what is observability? Observability is a feature of a system, which means you can extract the internal state of the system however you want. So it's not fixed like a monitoring dashboard where you previously calculated or had some idea that what you want to measure, and you measure those things. with observability, you measure multiple things and you will find out some new information as you go, as you need to dig deeper. There are 3 pillars of observability: metrics, logs, and traces, and we will look at them now a bit deeper. So we like to measure things or things in numbers. We measure our CPU cycles. We measure how much memory allocation our machine made. We are also measuring some other business aspects of. We also can measure some business aspects of our application. Micrometer library gives us some primitives here, and it's baked into the framework. For example, a counter can signal you how many times an event occurred. It's fairly easy to create for a Spring Boot application, but you can only increment it, and that's it. That's all about it. So one thing you can notice here is this meter registry. So in the previous versions of Spring, everything was magic and happened in runtime. With Spring 6, we see a paradigm shift here, where they are using more factory objects and make dependencies more explicit. So the GraalVM support would be much better for these tools, as it was in the tooling that was created in the past. Another thing that you can use is the gauges. And the gauge is for pulling one of your objects, numerical data out of your objects. It won't remember your previous, or won't remember the history of the different values. It's really just this. If you have something that pulls the metrics out of your system, it will, as the current state of the gauges, and display that one, and you won't see the intermediate steps. It's only for displaying the current state of something you are trying to monitor. And one last thing I want to show here now is the timer. I think it needs no introduction. So this is already you might be already familiar with the timers. The interesting here is also the metric registry. So you need to use a factory function, but after that, it is all provided that these metrics are exported to whatever system you are trying to get with it. So 2 things that I haven't shown you, because that needs a bit more setup, is distribution summaries, histograms, and percentiles. These are really close to each other. They just add to the previous one, add some new feature to the previous one. So distribution summaries, you can think of it as different buckets, and you can put some, you can increase some counters based on which bucket your data would fit. Histograms gives a time dimension on that, and you can create line charts from this one. And percentiles gives you some statistical function out of the box, so you can create charts that are the 95, 99 percentile. That's important when you are monitoring systems. But enough of this. Let's look how they look in some graphs. So right now, this is the base GVM micrometer dashboard. It's not really interesting, so let's get something more exciting than that. So I will be demonstrating some of these visualization tools with the LGTM stack. This is Grafana's Loki, Grafana, Tempo. So that's the 3 I will use. The M one I won't show you. Okay, so let's find. Grafana has already some like a marketplace for dashboards, so you can just download one that you like. So I think yeah, this one looks good. And I already have a process and some monitoring and some Prometheus and some metrics delivery running in the background meanwhile, while I was speaking to you. So we might be able to see some interesting stuff. So this is a nice dashboard because it demonstrates all the previous metrics that I was talking about in a visual way. So here you can see the counters and the distribution summaries, the histograms, and the percentiles also. Oh, something's not right because there's nothing here. Probably one of the script has been finished, yes. So we can come back here later and look at the percentiles a bit later. Okay, let's go back to the presentation. So these were the metrics. Next up is logs. What are logs? These are just messages that the developers leave on certain places in the application. If they think that an event that happened in the application or something that's going to happen in the application is important, they can write a message that will be written in the output of the application or in a file. It really doesn't matter where. They're just leaving something behind. The developer can give some information that's important in that domain context they have, but the other frameworks, like the logging framework or the Spring framework, can add on this some more contextual information that is important, that can help us to identify problems as they occur in systems. For example, one of these is the thread name or the class name that where the issue happened. One thing here to note is if you just write the standard log messages, that's not structures, might have some random structure. So introducing structured logging, as in you are logging as in a JSON format, can help the downstream systems to process your logs in a more generic way. For example, if you look at this one application I have here, these are JSON log lines. So the standard log lines converted to JSON, and at the end there's the little message that the developer wanted to leave for us, and all the other thing here is just context information that is inserted by the logging framework or the or the monitoring framework or whatever you have there. Okay, so again, let's look at Grafana. What does it have for us for logging? So we have a Loki setup here, which is a log aggregator, and Grafana can display the logs that Loki aggregates, so we can search here. And the basis of where the searches are labels. And I deliberately wanted to show you that this application, the log that is interested into Loki is not structured in this place, but Loki is able to work with that anyway. So how it achieves that, they attach some labels before ingesting the logs, so it can make some indexing on that and make the search faster. But also you can define some regular expressions and get the data out of the log lines as they arrive in some other way. So this way you can see what really matters for your application here. And the third pillar is tracing. That's a difficult one because our applications doesn't run in isolation. We always have some other microservice to connect to, a database, some cache, or a third-party system somewhere else. And if something happens, we need to find out what was the route of the request in our system and what events happened. And tracing can provide us with a solution. So all these events, all these metrics that we are logging can be grouped together, and we can look what happened in the system in context. So the information is correlated in this central place, like the Grafana, but you should use tracing with caution because it has some improved performance effect. So usually what we do is we introduce some sampling, like in the case of Prometheus with exemplars, that will filter to only a certain degree or only request that matching a certain condition, and attach tracing only to those. So if we go back Grafana, I think it already spoiled some of these. Let's look at the dashboard again that we get. So here, so we have some more data now. So here you can see these dim dots. This is where the traces are recorded. So there are many requests coming into the system, but not every request is selected for tracing. But the ones that are selected, you can see some additional information here about them. Why is this good? Because if you see some unusual thing in your graphs and your metrics, you see a spike, for example, you can look at the exemplar that what happened there. It will give you much more information than if you would just dig in your logs. And here you can see a button here that says query with tempo. This is a nice feature because it makes all the things interconnected, and you can dig deeper in problems. And I just selected the quote API, which calls into the quote service, so we can look at how the external service code is recorded by the observation, which is not recorded in this example. So let's find out what happened here. So if you look at our code, then I just copy-pasted the quote client generation from the first example, from the first application. And as I already said, there's no black magic with the new Spring stuff. So you have to work some by yourself. So with the default web client, we didn't get the observability feature. So we have to add it somewhere. So maybe in the factory builder. No, maybe before that, not really. Maybe the web client. Yeah, so we have an observability registry setter here, and we can inject it for this beam. And let's look at it if it's enough for this. So a while back, we used the metrics registry to get the metrics working, like the counters and gauges. Observability registry is a bit different animal, so the observability feature in Spring is you can use it directly, or you can use it as an annotation, but Spring also bakes it in most of their satellite projects, so you can opt in observability. It's not forced on you. It won't take your precious CPU cycles by default. If you want observability for your things, then you have to explicitly say Spring that this one needs observability. And if you have some other HTTP clients created with a factory like this, you can opt out on that specific web client from observability and spare some CPU cycles, which is nice. Let's see if the application is running. Looks like the application context already had this observability registry. So I said no black magic, but here some auto configuration happened because we had this dependency. But other than that, we had to work some to get this observability working. Or is it working? So it will be hard to spot another quote example here. So that might not be the right approach to have right now. So let's go back to logging, okay? And our app is the observability demo. I don't really care what happens here. It's too many things still, so maybe I will try a different approach. So we have a quote call somewhere here. That's definitely happened after we restarted the application. And we have the trace ID for this log. So let's just try to use that. If the line contains this, then we want to see, okay, so these are the two log lines that happened for quote call, and from the logs directly we can go to tracing. So we saw that in the previous one that we can go from metrics to tracing, and now we can go from logs to tracing. So this is a pretty nice feature of the GTM stack, that everything is interconnected and you don't have to work much for it. They designed it this way. So if we open up the tempo now, it's a bit more interesting right now. You can see that we had the server call that happened, and here in this other span, you can see that it did the API call to get our quotes. And you can imagine if you make more system calls or database calls, everything is added to here. So that's the short version for tracing. Spring, by including Spring micrometer dependency into your Spring application, you have you can have metrics on your SQL queries, or everything that is everything you can include in the Start Spring IO that have some observability feature baked in. If you opt in for observability, you can get observability for them, for those from Spring. So to summarize what we learned, that observability is a feature that you can query the internal state of your system. Metrics, logs, and traces help you identify what's happening in your system, but you need to deliver it to some center place. If you have all these data together, you can correlate them, make some query on them, or visualize them. Visualization is a good tool, so you can grasp the state of your system, how things are going in an instant, but it's also a nice tool to have to help developers understand their system. So without tools like this, it's a much higher bar to enter when you need to find like Kubernetes logs or SSH into servers through jump hosts. So it really just helps us onboard more people into this industry. About visualization, I almost forgot that here are a node graph, which if you click, then you can see that what other services and how these services interconnected with each other. So this is down here is the timeline, but this is a more static view that how much participant request processing had. So that's all by me, and thank you for your kind attention.